Hello everyone, welcome to egate.ai. In this video, let's talk about simple reflex agents. In the previous video, we had discussed a table-based agent. In that agent, there was a very big table, and in that table, we were storing all the possible percept sequences and their corresponding actions, right? So let's have a look on our previous example one more time. So in the vacuum cleaner word example, we had seen that we have to store a very big table for all the percept sequences and their corresponding actions. But if you will look closely, what is happening is that the action is mostly dependent on the last percept, right? If the agent is in B block and it is dirty, it will suck. And if the agent is in B block and it's clean, it will go to the left one, right? So basically all the actions are dependent on only current percept it will see, right? So we don't have to store all the previous percept history, right? We only need to bother about the current percept. So the agents who will act only based on the current percept are called reflex agent. So let's try to write the simple agent program for this reflex agents. We are calling it reflex vacuum agent. It will receive the percept. So this percept will have location and the status of the dirt, whether the block is dirty or clean. So if percept dot status, so this status will tell if the current block is dirty or clean. If this is say dirty, so in that case we have only one action to take, and that is suck, right? So we can simply return suck. So this is not dependent on the location, right? Irrespective of the location, agent can be in block A or block B. It will have to suck the dirt always, right? Otherwise, if the status is not dirty, then let's check the location, right? So if this location is A, right, then we will return move to the right block, right? Otherwise, else if percept location is, so if percept location is B, it will return left, right? So this is a very simple function. If the block status is dirty, agent will always suck the dirt. Otherwise, so if status is not dirty, that means it's clean. So if the status is clean, then it will check for location. If the agent is in A block, it will move to the right. If it is in B block, it will move to the left. All right. So we can write these kind of simple programs for reflex agents, right? So one thing to note here is that we are only looking for the current percept, right? So vacuum cleaner word is a very simple example, but even in that simple example, it will only work if the environment is fully observable, right? But if environment is partially observable, then there is a problem. All right, let's see what's the problem. So suppose this was your block A, this was your block B, and this was the vacuum cleaner, right? So suppose the location sensor is not working, all right, or there is no location sensor present and there is only one sensor that tells if the current block is dirty or clean, right? So in that case, the environment is not fully observable, right? It cannot see in which block it is, right? So if the environment is partially observable, what will happen? So suppose in the beginning, if say agent is in block A and it's dirty, it will suck the dirt, that's fine. But now suppose the current block is clean, so the agent will either move to the left or to the right, but the agent does not know whether the agent is in block A or block B, so it might try to move to the left direction, right? So there is a possibility that it will stuck in this infinite loop, right? Similarly, if the agent is in B block and the B block is clean, the agent does not know if it is in block B and it might try to go to the right of this block, which is not possible, and it will stuck in this infinite loop, right? We can have some tricks to avoid this infinite loop. What we can do is that when this agent perceives that the current block is clean, it might flip a coin. Okay, so if the head comes, it will go to the left, or if the tail comes, it will go to the right. In that case, on average, after 2 steps, it should move to the another block, right? It will not be stuck on the same block forever, right? So in partially observable environments, we often do these kinds of approximation. We call these kinds of agents as randomized reflex agents. Okay, so now since you have an idea of reflex agents, let's try to draw a diagram and understand it with more clarity. So let's look at this diagram. So we had seen some part of this diagram already. So we had an agent, environment, sensors and actuators that we already know. So this agent will perceive the environment with the percepts, and it will do actions with the help of actuators. So in reflex agents, what it will do, it will be only concerned with the current percept. That means what is the world right now, right? So from its sensor, it will only perceive the current percept. That means what is the status of the current world, right? And now we have current percept, and we have a set of rules, right? For example, in vacuum cleaner world, the rules were, if the current block is dirty, suck, or if the location is A, then move to the right. So we can write all those rules in if and else form that we had already seen in the example. So those are the condition action rules, right? So what action it will do, it will it will take the current percept, that means what is the world right now, it will check the condition action rules, and then it will decide what actions it has to take, and those actions will be taken by the actuators in the environment, right? So this is the block diagram of simple reflex agent, and this is very important to understand, because as we will see more complex agents, this diagram will have many other things. So let's now try to write a standard agent program for simple reflex agent based on this block diagram. Okay, so this is the standard program for reflex agents. It will get the percept. It will only have to persist the condition actions rule, right? So for example, in vacuum cleaner world, we had a condition action rule like if status is dirty, then suck, right? This was one of the condition and action rule, right? So we only have to just list 3 rules, right? If it's dirty, then do this, and if the location is A, then move to the right. If location is B, move to the left. There are just 3 condition action rules, right? So this table would be very small. So what it will do, basically it will interpret the percept, which we are calling as current state, and what it will do is that it will match, okay, this is the current state, that means this is the current percept, what rules are there, and given the list of rules, which rule is matching to the current percept, and it will give you that rule, and according to that rule you will select the action, right? And you will return the action from this function. So this is a program for simple reflex agents, right? So as we have already discussed, these simple reflex agents will work very well in fully observable environment, but that is not the case all the time. So you have to write the agents program that can work in the partially observable environment. So for that, in the next video, we will talk about model based agent. Thank you so much.